so in section 7.2, we're doing the opposite of what we did in our last section. We're taking the postulates and theorems we learned last time, and we're doing the converse. We're flipping them around. So instead of, last time what we learned was instead of saying if the lines are parallel, then corresponding angles are congruent, we're turning that around. So it's if corresponding angles are congruent, then the lines are parallel. So we're doing that with each of the three postulates and theorems we learned last time. If alternate interior angles are congruent, then the lines are parallel. If same side interior angles are supplementary, meaning they add up to 180 degrees, then the lines are parallel. Notice how each of these statements end with then the lines are parallel. So what we're doing today is being able to prove whether lines are parallel or not, or which lines we can prove are parallel. You'll see some examples in a minute what that's going to look like. So just a reminder of what corresponding angles are. Corresponding angles are in the same corresponding corners of the intersections. So when you have two lines and a transversal, this is one pair of corresponding angles, but there are three other pairs. One here, and one here. This one is alternate interior angles. There are two pairs of alternate interior angles in this picture. There's one here. Notice there are on alternate sides of the transversal, but they are inside the parallel lines. That's where the word interior comes from. Interior is inside the parallel lines. Alternate is on opposite sides of the transversal. So there's another pair of alternate interior angles here. Same side interior angles are the ones that are not congruent. Notice how here these are both obtuse. They're the same size. These are both acute. They're the same size. But here we have one that's obtuse and one that's acute. There's no way that can be congruent. Instead, when the lines are parallel, those types of angles, same side interior angles, add up to 180, which we call supplementary. So notice how they're on the same side of the transversal, but they are inside the parallel lines. That's where the word comes from. Same side, interior, inside. Okay. So these are the only three ways that we can use to prove lines parallel. The other angle pairs we learned about do not prove that lines are parallel. The other two angle pairs we learned are vertical angles, which are congruent, but that's not going to prove any lines parallel. Are there any parallel lines in that picture there? No, there are no parallel lines needed to create vertical angles. Vertical angles are simply two crossing lines, which are not parallel. So you cannot use vertical angles to prove that lines are parallel. They're still going to be congruent. Vertical angles are always congruent. But that's not ever going to prove that lines are parallel. Okay, the other type of angle pair we learned about is adjacent angles, or a linear pair. And those type of angles form a straight line. One's acute and one's obtuse, and they'll always add up to 180 degrees. But again, in order to make adjacent angles, do we need parallel lines like we did on these types of angles? No, we don't have any parallel lines. It's just simply two intersecting lines, again, that are creating two angles that are next to each other that add up to 180. So adjacent angles do not prove lines parallel. The only three ways to prove lines parallel are these. Okay? So I wrote this question here. Will these two types of angles prove lines parallel? The answer is no. So if they give you any of those on your assignment today, you just have to say none. You can't tell which lines are parallel because this doesn't tell you. Okay, we need to look at some examples. If you want to write down any of these examples, you're welcome to. Or you can just kind of listen and get the hang of this. Alright. Do you guys still need this?